This LOS is demonstrate the use of a timeline in modeling and solving time value of money problems. Okay, the best way to learn this LOS is by doing a couple of practice problems, and that's exactly what we'll do. So we'll look at, this is kind of a two-part problem, and these are important to understand. So grandparents are funding a newborn's future university tuition costs estimated at $50,000 a year for 4 years, with the first payment due as a lump sum in 18 years. That's 18 years from now. Assuming a 6% effective annual rate, the required deposit today is closest to $60,699, B, $64,341, or C, $68,201. Okay, there's a couple of really important things with solving these type of problems. So first we're going to start with the timeline. So we read the question. Their grandparents are funding a newborn's future university costs. It's going to be $50,000 a year for 4 years. So there's my $50,000 a year for 4 years. And it's going to be, the first lump sum is in 18 years from now. So that's 18 years from now, we need a lump sum. So one is understanding the timeline. That's in the future. We need a certain amount, but we need to know how much is that worth today. And so there's a really key important issue here, and it's regards to which mode your calculator is in. If it's in the end mode or the beginning mode. You can solve this question both ways, but if you get your timings wrong, you're going to get the wrong answer. So you can see if I'm in the ending mode, then at the beginning of the 18th year, that's at the end of the 17th year. So if I'm running the calculator in the end mode, when I go and do my present value formula, I'm going to be using n equals 17 because it's at the end of the 17th year. If I use 18 and I'm in the end mode, the answer is going to be A, and I'm going to get the wrong question. So this is really important to understand the timelines. The payment is due at the beginning of the 18th year. That's at the end of the 17th year. So if I'm in the ending mode, my n is going to be 17 when I go and do the present value. So as I said, these are two-part problems. They have to be done in 90 seconds. And if you don't pay a close attention to detail, there's the possibility that you can get something wrong. So first of all, let's solve the first part of it. And that's the $50,000 a year for 4 years. We're just going to do a present value. So the first thing that we're going to check, I'm in the ending mode. Second, PY. Oh, we're here at 365. We're doing something with the daily. So I'm going to change that to 1. So it's not talking about semi-annual. It's just going to be annual. So let's just see here. We need a payment of $50,000 a year. So it's going to be $50,000. And that's going to be a, it doesn't matter if it's cash out or cash in. 50,000 payment. It's going to be 0 future value, okay? And it's for 4 years, 4N. And we know 6 IY is the interest rate. So we're going to compute the present value. So I can see it's 173,255.28. So at the beginning of the 18th year, I'm going to require $173,255 and 28 cents. Okay, so now so that's how much. That's the lump sum that I need at the beginning of the 18th year. Now remember, that's at the end of the 17th year. So if I'm in the ending mode in the calculator, so that's going to become my future value, correct? So I'm just going to I can just go like that, hit the plus or minus key, and I can enter that straight away as my future value. So that's going to be my future value. Again, there's going to be no payments, okay? It's still the same 6 IY, but now again, it's at the end of the 17th year, the beginning of the 18th. So I'm using 17 as my N. And when I compute the present value, it's 64,340.84, which is closest to B, 64,341. So as I said, if I used 18 as my N and I compute my present value, 60,699, I would have chosen A. So you got to be very careful, these two-part problems. So read it very carefully. It says due as a lump sum in 18 years. That's at the beginning of the 18th year, which is the end of the 17th year. So the first part should be easy. Present value of 50,000 for 4 years using zero future value at 6%. Getting that number should be really easy. The little trick here is that you got to use 17 as your end, not the 18. And so I draw that little timeline here using it's the end of the 17th year, okay, which is the beginning of the 18th. Okay, hopefully this slide doesn't confuse you. What I did is I'm just solving this using the beginning mode. So we know that it's the same question, and the payment is due at the beginning of the 18th year. And sometimes it's just different strokes for different folks. People understand things differently. So if you want to solve this where n equals 18, then you need to begin, the payment is due at the beginning of the 18th year. Then you need to be in the beginning mode from the beginning of the question. So how do we put it in and I just did this as a bit of a review on the beginning mode as well, which is important. Sometimes you get that with different type of annuity questions, etc. So to put it in the beginning mode, you have to do second, begin, second, enter, and then hit clear. And you can see now I've got the little BGN on my screen. Okay, so now I know I'm in the beginning mode. So then the first part of the question is basically the same. I need a 50,000 payment. So it's 50,000 payment, and there's zero future value. And I'm using the same 6%, so 6 IY, and that's for 4 years, correct? And so I'm going to compute my present value. So you can see here it's a different number because I'm using the beginning mode. So at the beginning of the 18th year, I need 183,650, okay? So again, I can just hit the plus or minus key and make that my future value. And of course, there's no payment, right? Using the 6 IY, but now it's at the beginning of the 18th year, so I can use 18 as my N. And so when I compute the present value, boom, I get the same answer. It's 640,341, which is B. So the last slide I solved it in the ending mode. This slide I solved it in the beginning mode, and that really was important to understand that when I'm in the ending mode, the beginning of the 17th year is the end, beginning of the 18th year is the end of the 17th year. So you just have to really pay attention to that on these two-part problems, okay? Getting your N right and getting your timing right. So this is just another practice problem that's very similar, and it's dealing with an annuity as well. So a German pension fund manager anticipates that benefits of 1 million euros per year must be paid to retirees, and retirements will not occur until 10 years from now, okay? 10 years from now, T10. Once benefits begin to be paid, they'll be paid until T equals 39 for 30 payments. So that's good. They're giving us the N equals 30 payments. What is the present value of the pension liability if the discount rate is 5% compounded annually? So again, we have to calculate the first part. There's going to be 30 payments. So let's just do that. It's going to be 30. And before I do anything, I always check, second PY, we're still in 1. Aha, I'm in the beginning mode. Maybe I don't want to be in the beginning mode. Second begin, second enter, and I'm going to clear that. And now I'm no longer in the beginning mode. I'm going to solve it the same way as I did the first part of last time. So now I know 30N. I have to calculate how much is that liability in the future. It's 30N, and the interest rate is 5%, 5 IY, and I have to pay $1 million a year. That's going to go out. So I'm going to do that as a plus minus key, million out. That's a payment, and no future value because that's the length that I need to do. And then I'm going to compute the present value, and you can see I've got 15,372,451 euros. Okay. Now again, this is the same thing. That is due at the beginning of the 10th year. I think you're getting my point now, right? Which is the end of the 9th year. So if I'm in the ending mode, okay, I'm going to make that plus or minus key. I'm going to make that my future value, okay? And I have 0 payment. And I have using the same 5 IY, 5%, 5 IY. And now this is the key thing. It's beginning of the 10th year, which is the end of the 9th. So I'm using 9 N, and I'm going to compute the present value, and I'm going to have 9.9 909,921. Okay, so this wasn't a multiple choice question, but it was just working through the same type of problem, just for a little bit of extra practice. Using the timeline, the beginning of the 10th year is the end of the 9th year. Ending mode, that's the key. Okay, I'm in the last slide for this LOS, but I'm just solving the same problem again using the beginning mode, different strokes for different folks. So that payment is due, that first pension payment is due at the beginning of the 10th year. So if I want to use n equals 10, then I need to be in the beginning mode from the beginning of the question. Okay, so that's second, begin, second, enter, hit clear, clear. I see the little beginning mode. So I know it's the same type of thing. So it's 30N. I have to calculate the pension liability in the future. So it's 30N. It's 5 IY. It's a million payment that has to go out, €1,000,000 payment, 0 future value. So I'm going to compute the present value, and I'm going to get 16,141,073. Now that's a different number because I've used the beginning mode, okay? But now I know that's due at the beginning of the 10th year, and I'm in the beginning mode, so I can use my n as 10, okay? So again, I can just make that my future value, 0 payment, 5 IY, and now that's the beginning of 10 years, 10 years from now. So I can use 10 equals n, compute my present value, and I'm going to get the exact same number, the 9,909,218 euros. If I just go back to the previous slide, yeah, you can see we have the exact same number. So that's just a little bit of practice using the timeline. It's always very similar type questions. You have to calculate the present value in the future. In the future I have this liability, so what's the value of that? And then I have to discount it back to today's date. And the key here is understanding at the beginning of the 10th year, it's the end of the 9th year. At the beginning of the 20th year, it's the end of the 19th year. So you have to pay close attention to your calculator, beginning or ending mode, and getting your n right for that second part. Okay, thank you. That's it.